Hello everyone, my name is Hans-Peter Bakker and I'm going to be presenting a short-ish webinar on the power of plastics. Basically we're going to do a 3D experience and also a SolidWorks Plastics analysis, and we're going to look at both and see the comparisons and stuff and as we go. So I did a webinar already, but I didn't record it, so I'm busy doing a recording, so if you don't see my face, that's why. Let me just move this around a little bit. Okay, I think we're happy. So power of plastics. So I'm an engineering graduate and an applications engineer, and I'm based in Cape Town. And I hope you guys enjoy it. So today we're going to be doing a few things. We're going to look at simulation and the power of simulation as in itself and what it can do for you. We're going to talk about the power of plastics on its own and what it is. And then we're going to deep dive a little bit into SolidWorks Plastics, and then 3DEXPERIENCE Plastics, and then we're going to do a little demo at the end. The thing that I want you to keep in mind while I'm talking is that plastics is... so 3DEXPERIENCE Plastics and SolidWorks Plastics can actually do very much the same things. They have different pros and cons, but we'll talk a bit more about that as we go. So the market trends of simulation. If you look at this little plot here on the right, we see from 2010 to 2030, we have a steep increase in the reliance of simulation by engineers, right? And what that's doing is our time to solution is massively decreasing. So there's definitely a correlation between the two of these things. Like if you can run a simulation before you actually make a prototype, you don't have to waste that prototype. That's just it's the simplest way to put it. So you can make innovative products before your competitors. So you basically, time is a big factor here because you can test stuff before. You don't have to run multiple iterations. You can reduce your cost and your time of physical prototyping. So you can do virtual testing. There's no need to make a physical prototype as in this new world. You can accelerate your product development. So with these time constraints, with these lesser time constraints, you basically can come to a better product because you can accelerate your product, your design process, and then have more time to actually develop the product as you like. There we go. You can improve product quality. This is a big feature. You can make informed decisions based on previous, virtual results. So basically, simulation is a tool to design better products. So that's the whole point of it. So it's not about reducing time. It's not about saving costs. Obviously, these are factors, but these all lead to having a better product in the end. So quickly, I want to talk about where SolidWorks simulation and plastics fits in. So we have a lot of simulation tools here in the SolidWorks package. You can have let me just get my little pointer out so I can show you what I'm talking about. So you have simulation standard, which is just these three. But this is still super powerful, by the way, just so you know. Then you have simulation professional, which has all these extra little parts. Like you have topology, optimizations, you have frequency analysis, drop tests. This is really, really, really powerful. Then on top of that, at the highest level of SolidWorks simulation, you have simulation premium, where you have dynamics, nonlinear, and composites. These are really, really hyper advanced stuff. So what I want to kind of talk to you about is plastics. So this is what we're going to talk about here. What you must know is plastics sits separately from these standard tools. So plastics is its own thing. You have a standard, professional, and premium, which exists outside of the actual standard simulation tools. So you could have simulation premium here, but you could have plastic standard. So that's completely up to you. Also, here's Simulia. We're going to talk a bit about this. But the plastics version. I've talked about the Simulia in a previous webinar. So yeah, if you want to just check that out. So that was simulation. That was simulation. We've talked about simulation, what it can do for you. But now I want to talk about plastics. So let's talk a bit about plastics. So what is the difference between SolidWorks Plastics and 3DEXPERIENCE Plastics? So like I mentioned before, there aren't that many differences. They can actually fill the same roles. For your business, they can give you the same things, but they have slight differences. For example, 3DEXPERIENCE is more scalable. You can buy a license for a short amount of time for just one project and then use that again. SolidWorks, in the next point, has a couple more specific features, but 3DEXPERIENCE has its own fair share of them. So mostly when I'm showing pictures and talking about stuff in this webinar, really they are very similar. It just depends on your pricing model, your interest, and your pre-existing knowledge, which we talked about in the last slide there. Another thing is the meshing capabilities within 3DEXPERIENCE are industry leading. They are insane. They mesh your parts mesh very quickly and automatically. You can change your mesh if you choose to, but most of the time it does it for you. You don't even think about it. Then you have local cloud solvers. So SolidWorks is a local solver. You can't solve your stuff on the cloud, but you can solve it, on an external simulation, like computer or something like that, if you needed to, like a server. But you can also do that with 3DEXPERIENCE, and 3DEXPERIENCE you can solve on the cloud. So you can literally just make your simulation, set it up, offload it to the cloud, and then come back to it when you're done. It's amazing. And you can keep working, you spare all your hardware for that time that you're actually simulating. And then pre-existing knowledge or preference, more like. So, it depends really what you're used to. If you're used to SolidWorks, Plastics kind of fits right in there. You don't really notice the difference. It's very similar. But with 3DEXPERIENCE, it's like it's a whole new thing. But that might be exactly what you want. I don't know. So this is Plastics, right, for you. So if you look at the bottom, you have the process that you have to go through to get a plastic product. You have part design, mold manufacture, part production, and product launch. And each of these is a different step that you must go through to actually get a finished plastics product. So, but what I want you to focus on is these two plots over here. So you have the orange plot, which is cost of change. So at any point in this process, if you have to make a change, this is what you will spend, right? In the beginning, it's low because you still design the part. But if you have to make a change after the product is launched, that is a massive cost, truly. Then on the other side of things, we have impact of change. So we have part design, mold design, the same exact process, but the earlier you make a change, the bigger the impact on your business. So what Plastics allows you to do is to make the changes super early, like in here or here, but if you didn't do that, you'd have to get all the way to part production and then make a change. And then your cost is higher and your impact is low. Where here, if you do it in the very beginning, if you make that change early, you save having to create a new mold. You save having to, set aside time to create however many you choose to. Basically, the sooner you can do it, the better. And that's what Plastics allows you to do. So on that note, why would you choose plastic simulation, right? So 3DEXPERIENCE SolidWorks Plastics. So I've said 3DEXPERIENCE SolidWorks because we're still kind of talking general. Like this is what I'm saying. Like they integrate very well. They kind of do the same thing. 3DEXPERIENCE SolidWorks Plastics delivers easy to use simulation for analyzing plastic parts and injection molds. So you can completely analyze things before you even design while you're designing. It can actually simulate how melted plastic flows during the injection molding process. This is crazy that it can actually do it. This is an insanely advanced type of simulation. So it can save you money and time and effort, and really is worth your time. It can also predict manufacturing related defects, so you can quickly evaluate part manufacturability while you design. So we talked about this a bit. I've harped on it a lot, but while you are designing the part, you can test the manufacturability of it. And then if something doesn't work, you can make a change in the design phase. You save yourself a great deal of effort and effort, I would say. So the value, why is it worth your monetary and your time? Why is it worth it? So greater than 80% of plastic parts are injection molded. So most parts that you see that are plastic have been injection molded. I'm sure you know this if you are an injection mold engineer. So injection molding is a complex mix of time, temperature, pressure, material, and tooling variables. So it's very, very hyper complex, and it's difficult for a person to do it properly, because there's an insane amount of experience necessary, where you could give this tool to a young designer and they can learn without having to make a bunch of prototypes that fail. Injection molds can range from over 70,000 Rand to over R1 million. And to rework that mold is very costly and very time consuming. But look at this little thing over here, down here. So using SolidWorks plastic simulation to avoid just one round of mold rework can result in a positive return on investment. Basically, if you can use simulation, plastic simulation, to avoid one single mold rework, you have essentially paid that year for that plastics thing. And that will happen very quickly. So it really is just worth your time, I must say. So plastic capabilities. The main things it can do: it has an extensive database of materials, which is very important. It has a comprehensive range of analysis capabilities and results, can do pretty much everything. And it has a guided analysis setup and results interpretation. So this is SolidWorks, but it is honestly both. Like I've said before, they really are similar. So the elements differentiation between SolidWorks and 3DEXPERIENCE and the rest. So keep in mind, they both integrate very, very nicely with SolidWorks. If you have SolidWorks already, you can just draw, the parts actually integrate very well. It's within the SolidWorks environment. And this is both 3DEXPERIENCE and SolidWorks. It's easy to learn and it's very easy to use, and it's very fast and accurate. So we've talked about plastics. What are plastics? Let's move on to SolidWorks plastics. So this is essentially these slides and stuff come from SolidWorks, but most of these capabilities are available in 3DEXPERIENCE once again. So you have to ask yourself as a designer, can this thing be molded? Where are the air traps? Where are the weld lines? Where are the sink marks? How uniform is the flow front? So if you see this picture over here, you can see this is a short shot. The thing hasn't actually generated. And this is simulated first, and then it matches with the real world counterpart. So you get these 4 different investigations in the flow front of the plastic. So you can tell the thing, I want to inject there, and then you can see how long it takes. You can see the pressures. You can see everything as it goes. You can see multiple injection locations, like down here. And you can see if I look at these two versus this one, this is a much more uniform flow front compared to these. So realistically, you can have less problems with this top right one than you are these. You can also see, so this is basically you can see the flow front. So you can see how this is caused by pressure and viscosity and stuff, and you can see how the flow front changes as it goes. Obviously, this is more desirable than this because this will create an air trap, and we'll see now. But here you can also have these cool little plots that show you exactly the time as the plastic flows. You can see exactly these little contours. And then here, look, so this is that one I showed you earlier. You can see the plastic goes around and forms a little thing over here. This is an air trap. So the air would get trapped in here and it would cause big problems unless you have to create an air trap there. So you can tell the software where to make air traps. So here you can see a bunch of air traps. This is where it tells you need to have air traps or else it won't work for you. So you can even little things like that. We've talked big stuff like reworking a mold, but in reality, just, being able to design your product very quickly, knowing where the air trap's going to be, saves you money and time straight away. Also, it can predict weld lines. So where the plastic meets, you get these little weld lines where like the front of the plastic meets another front of plastic, and then it's essentially can be a high stress concentration area. So basically, you want to make sure that this is not happening on a point that's going to take stress. So it's very nice that you can do that. And then sink marks. This is just from the cooling of the plastic and the filling of the plastic. You get these marks, and it can actually even predict that. So more questions. How many parts can be molded at once? How many gates do I need? And how do I need to size my runner system for balanced filling? So if we talk about the first one, how many parts can be molded at once? That's up to you. That's the strength of your computer. Honestly, you can mold as many as you want. You can see we're molding a whole bunch of different gate locations as well. And you can see how many gates you need. That's the answer. This can give it for you. So if you look at this picture, you can see the left side fills quicker than the right, and you get this uneven fill. So what they can do is SolidWorks can resize your runner system automatically to fill the whole volume at the same time. So it automatically fills it, and then tells you see it fills exactly the same time. It tells you how big must your runner system be on each side to get that. It's really powerful. So more questions. How long do I need to pack? What's the performance of my cooling system? What is the cycle time? All of these questions can be answered with 3DEXPERIENCE or with SolidWorks. In this case, this is the SolidWorks user interface. Very, very nice. You can see how easy it is to distinguish different colors. You see these little blue things. These are actually coolant lines, not in this one, the previous one. And you can essentially simulate the cooling of the system. So you can see if your thing will actually cool properly. Then these are cooling lines, and we are going to see how the part warps as it cools after it's been ejected. That's the crazy thing. So you get, what is the final shape? How does the shape warp? What are the tolerances? All of these answers can be given to you by SolidWorks or 3DEXPERIENCE. It's really, really cool. So a little bit more about SolidWorks. This is within SolidWorks Premium. You get different types of meshing. You get the tetrahedral mesh on the left, and then you can even do hybrid meshing, where you have tetrahedral mesh on the interior, and you have these more square triangular prism meshes on the outside. It's really, really cool stuff. So two different mesh types for different situations. And you can do, if you have the expertise, you can do kind of whatever you want. So this is insert overmolding. It's a toothbrush, and you can actually have a toothbrush part, and you can insert an overmold over it. and then it can mold over it. That's really cool, little features. Then this is another overmolding, but you have this electrical connectors, these copper pipe things, in the middle. So the plastic runs over them, and you get these like nice little molded sections. So this is really cool. Fiber analysis. So this is also within SolidWorks. It can actually tell you how, as the plastic flows through the part, how the fibers are going to look within it. So if you have a stress concentration issue, you can very, very easily like alleviate that by knowing the way the fibers go. So, you know, like you as a designer, it just gives you tools to do anything. You can choose whatever you want, and you can fix and solve whatever problems you choose. Then we have birefringence. This is really crazy. So this, SolidWorks can actually tell you the refractive qualities of plastic that you have injected. So basically what happens is, due to different temperatures and pressures and stuff, a piece of, you know, plastic will have different refraction qualities. Like, you know, you get these little rainbow things, like if you look through glass a certain way, or different plastics. So what this thing can do is it can tell you how it's going to react. It's going to give you, like, it's going to tell you exactly how it's going to look with from different perspectives, and you can fix that. So if you're 3D printing something, or you're injecting like a lens or something like that, you can literally just solve it with this problem, with this capability. Then you get gas-assisted injection. So often you need to hollow out the interior of a plastic part, so you inject a gas through the center, and you can actually even simulate that. You can also simulate separate valve gates, so you can time the gates to eject at certain times. So you can experiment with what is the most optimal for fill time, for pressures, and, you know, for ease of fill as well. So that was a bit about SolidWorks Plastics. Like I said, a lot of the capabilities are in 3DEXPERIENCE, but maybe not all the high level ones. Like, I'm not sure exactly, because, you know, there's a million qualities, but there are so many that are similar. So let's talk about 3DEXPERIENCE Plastics for a second. So this is the plastic injection engineer role. And you can see with the role comes a whole bunch of different features. So you have bookmarking, which is file management. You have collaborative lifecycle, which is a PLM system. You have credits and tokens for cloud solving. You have Simulation Finder, which can actually help you find a simulation within your system. You can define new materials. You can find products. You can monitor your cloud jobs. Like a million different things. Change action is another part of the PLM system. You can even convert for step files and IGES files. And then here's this plastic injection right here. So this is the thing. This is what we use. This is the actual role. So this is the role, and each of these are apps within it. So it's a little bit of a different system, but yeah, let's talk about it. So you can virtually test the performance of plastic parts and mold tooling designs with intuitive guided simulation assistant that minimizes the learning curve. So you have the assistant, which makes it much easier. You can cover the needs for all industries, all key workflows, and all user personas with a single role. As well as you can predict common molding defects, including weld lines, sink marks, air traps, and incomplete filling. So you can do all this stuff in SolidWorks, but 3DEXPERIENCE does it too. So another thing you can do is you can validate the effectiveness of these two, which we've kind of talked about already, but you can also apply advanced structural capabilities available in the 3DEXPERIENCE platform, such as nonlinear, multi-scale material modeling directly on a common model. So it's really, really powerful, because you can have a SolidWorks part or a 3DEXPERIENCE part, and you can actually run it on this plastics role. You can also leverage process automation, designs of experiments, and advanced optimization tools available in the 3DEXPERIENCE platform. This is something really important, because 3DEXPERIENCE is like its whole own thing. It's like a world, right? And it connects all these different industries. So if you have a plastics role, it's super integrated with all these other roles within 3DEXPERIENCE. So you can kind of do whatever you choose to. You can combine it with all the PLM systems. You can combine it with all the task management and all the other design tools. Really, really cool stuff. So let's look at a little video about plastic injection.
From personal electronics to home appliances, office furniture, and even medical devices, plastic products are everywhere. Optimizing the design and manufacture of these products can have a huge impact on their overall performance, quality, weight, cost, and time to market. The plastic injection engineer role on the 3DEXPERIENCE platform is an essential tool to validate and optimize injection molded plastic part and mold designs. Starting from SolidWorks, you can connect to the 3DEXPERIENCE platform using an integrated workflow that enables you to easily save, manage, and share your design in a secure, cloud-based environment. With the plastic injection engineer role, you can use a guided workflow to quickly set up and simulate the filling, injection molding process. Product designers can assess the manufacturability and quality aspects, such as weld lines and air traps. When issues are identified, you can make a design change in SolidWorks and quickly return to the 3DEXPERIENCE platform to rerun the simulation and evaluate the results. Furthermore, mold designers can evaluate and optimize the feed system and cooling circuit designs. You can also simulate advanced molding processes like two-shot overmolding. With Simulia's Plastic Injection Engineer role, you can take control of your plastic part and mold designs to eliminate mold rework, improve part quality, and decrease time to market.
Cool. Yeah, so really interesting. It shows you how you can integrate SolidWorks and 3DEXPERIENCE. And yeah, it's very, very, very cool stuff. So that was a 3DEXPERIENCE Plastics. Let's move on to the plastics demo. So I'm going to literally just talk. I've done a demo and I want to show it to you guys. And it was all within 3DEXPERIENCE. And yeah, it's really, really cool. So basically, this is a 3DEXPERIENCE. This is how it looks. This is the user interface, and this is exactly what you can do. So that's MeCAD Sales. That's what I'm using, but that's a different platform that you can each one can be its own. I've created this whole dashboard. All of this was done by us or by MeCAD, and this is something you can edit yourself. It's almost like a website that you can change on the fly all the time, and everyone can see the same thing. So these are all the apps that I have with my role. And yeah, they're very, very, very powerful and very useful. So let's look at them a little bit more. So this is design with SolidWorks. This is what we're going to use. So this literally lets you integrate SolidWorks with 3DEXPERIENCE. So any part or any capability within 3DEXPERIENCE can be integrated. So that's the plastic injection app, which we talked about already. And let's look a bit more at it. So we close that, and now we can close this window and we can look at everything. So what I do is I can go to the search bar and I can just search. Also remember, this is all in a website, all of this. You can access this from anywhere as long as you have the credentials. So I search sew, and you can see there's different sewing machines. There's the A revision, a B revision, and a C revision over there. And I've made different revisions to make changes in the part as I've been playing with it and experimenting. So I go open with, and you have all these different things you can open with it with, which all have different powers, capabilities. Let's go to design of SolidWorks. So what's going to do, press it. It's quite a big part, so it might take a second. But basically what it does is it opens up so it takes a part in 3DEXPERIENCE, and it takes it and it literally opens it into SolidWorks. So it just pops it up in SolidWorks. And okay, so we're opening a very big part because it's got a whole bunch of moving parts and mates, which I'll show you. So this takes a while, but it would anyways, depending on who you are and what your kind of computer is. So if we look on the right-hand side, this is the window that is the 3DEXPERIENCE add-in into SolidWorks. It's really, really cool. So it essentially lets you get the power of 3DEXPERIENCE directly from your SolidWorks. You can do, product life management. This is a little error about camera targeting, just for messing with the part. And you can see there's a lot of information here on the right. Don't get overwhelmed, don't worry. It is actually quite straightforward once you get a hang of it. So this is the part we opened, and you can see if I take that little wheel and I spin it, the actual little thing moves up and down. So the whole thing is literally a working sewing machine with all the parts mated correctly, which is crazy. Just by the way that we can do this, it makes me very happy to actually be a part of it. So what I want to do is I want to show you how you can kind of integrate the two between SolidWorks and 3DX. So what you do is if you press a part in the SolidWorks environment, it highlights a feature in this feature tree on the right. So vice versa, if I press one there, you can see a little highlight, little box there. So it's almost like you have your own feature tree. You almost don't even need the one on the left. You can use this feature tree for pretty much everything you need, as well as this thing is integrated with the cloud as it goes, as well as a PLM system. Oh, it's crazy. So if I press this face, which is what I want to use, I right click it and I say open. This is all real time, by the way. Boop, straight away opens it into SolidWorks for me. So now I have this part in SolidWorks, and I'm going to do a simulation on it. That's my plan. I want to see if I can fill this part and see how it works. I could do it in SolidWorks Plastics, but I'm going to do it in 3DEXPERIENCE. And it's this easy. So this is the window we have. and it shows all this information. It shows revision, maturity state, description, file name, the collaborative space it's saved in, all cool. So I have to lock it, which is essentially like in PDM where you check out a part. And now I can edit it and change it and do whatever I want. It's not my part as long as I have locked it. So I've done that. You can see you can drag this window. It's completely editable. It's up to you. So I make it smaller so I have some more space. And I can literally go to 3DEXPERIENCE straight from here. So I search plastic injection and I press it. And what this does is it launches plastic injection and it takes my part and it puts it into the plastic injection environment as a simulation part. I can just run a simulation on it straight away. It really is that simple. So it obviously opens up a launcher, and then so I open another screen to just drag it across. And yeah, so that's what we get. So we have the part now in the 3DEXPERIENCE environment. On the right, we have the assistant, which has parts, materials, all these things. Don't think too much. It's not too complicated. It's literally just it helps you to set out your simulation, because you literally go top to bottom. You go boom, boom, parts, materials, post settings, and it literally helps you. So you see if I press parts, it shows me, oh, okay, that's what you need. You need a contributing part. So I have to decide which parts I want to contribute to the simulation. I say I want the whole thing. And then I need to tell it what that part is. So I go there and I press this little icon, and I can decide what this part is to me. So you can have multiple parts and then bring them in, and you can even insert parts now. And then you can make, you could bring in a piping system, make it a cooling system or a hot runner system. That's up to you. So now what it's done is it's decided this is now a plastic. You can literally go straight there, press materials, and then you can create materials. You could also have gone in the assistant and press materials. And I want you to look at that, 4,216 plastic materials inside this environment. This is just plastics, by the way. This isn't any other parts, no metals, just plastics. So over 4,000 plastics within this environment. That is a massive database. And you can see with, like, if I go to ABS, there's 408 different ABSs. So it's very, very likely that the plastic you need is here, or at least a very similar one. Also, this thing is a cloud-based platform, so it constantly adds more. And you don't have to do it. You don't have to do anything. It just automatically brings in, like, you'll go in, run an update, and it will be there. So if we go to process settings, this is all the settings for the simulation. You get shared settings, plastic flow simulations, pack simulation, mold, melt, heat transfer, mold thermal simulations, and summaries. So you basically get all these different parts of a simulation. Really, really cool. So I made it a bit big for the screen, so I'm just going to drag it up and then exit it there. So you can see how many settings you have. You have total control of your simulation. You can do kind of whatever you choose. And this is all really how simple it is. You go to conditions, you can press auto injection. Then you can choose a part, you can choose the diameter of the actual injection location, and you can see how many locations you want. And you can also exclude faces and stuff like that. So let's say we want one face, one location. We say find locations, it calculates it, and it pops up over there. So it says that is the ideal location if you want to just do this size and you want to inject that way. So this is essentially how you set out where you actually want to. But you could also obviously, you see there on the right, injection location. So what I've done now is I've said 3, and now it selects 3 different points, and it shows me how they would actually fill. So the green one versus the yellow, that's kind of a guess of how it will fill. So let's go back to 1, and then you press OK. And then, because I still have to go back and actually change it, because it is now 1, but now I have to go back and reselect just for the view. So it's going to ignore the ones that we used already. We say okay, we just select 1, we say find location. So it just wasn't highlighted before. So now it's going to highlight them. We highlight the one location, say okay, there we go. Whole part is now, we have 1. So if we go to simulate, we press simulate. This is, so now there are different ways of solving. You get the cloud solver and you get a local solver. This is what really is so cool about 3DEXPERIENCE, is you get these different options. You can simulate, on your local PC. If it's overnight, you don't need it, it's fine. It's, maybe you understand it a bit more. This is also fill, pack and cool, warp simulations. You can do all these different things. So we're just going to choose a local solve because I haven't set out the tokens yet, but that's okay. We don't have to. So I can choose how many cores I want to actually use as well. So I could tell the computer, like, only use 4, it's fine. You don't need to use that many. I say okay, and then it's going to run. And basically, this took about 5-6 minutes. I'm not sure how long, but I'm going to skip ahead because I don't think you need to sit here and watch the whole thing. But this is all still live. This is exactly what happened. So you can see it's busy loading, it's busy thinking, and then a little simulation window is going to pop up. It's going to say, and also this is the automatic meshing that I was talking about. So this is the mesh it came up with. We can change this if we want. We can easily change, but I chose not to. I'm just going to leave it like it is. It's quite dense, as you can see, so that's probably why the simulation took so long. But it's dense as well, which is not necessarily a bad thing, because we have a lot of small little parts. This is actually a big part to plastic injection mold, and it's a big part to simulate. So pretty cool stuff. So if you look on the window over here, it's busy solving the simulation. It's still initializing it. Once we actually get like there, so now it's said, okay, cool, everything is set. Let's start the maths. This is the flow rate into the injection location. And then we can also go and we can look at different plots as it solves. And it's quite intuitive. Like you go to flow rate, it shows you the flow rate as the thing goes on. You go to maximum injection pressure, so it shows you it's still increasing, which is what we'd expect. Minimum temperature, max temperature, these are just temperatures of the plastics within the product. Then you get the full percentage. So this is probably where I'd leave it, because it shows you how far it is. So this is going, and then it's going to speed up in a second. There we go. So it goes like that, and then it runs. But I skipped the end, it's fine, we don't need to see the whole thing. But let's look at this. This is the finished product. And this little dialog box on the right shows you the step, which is essentially what which simulation we're using, and then different plots. So this automatically populates. You don't need to go and set these out beforehand. This just was like this. I didn't do anything. You press the little play button and it plays animation showing the pressure as the fill goes on. Then let's go to full time and look at that. It fills, it shows exactly how the plastic would fill the whole model. Then you can look at, there's a million different little plots here that you can use. And these are just automatic. You don't need to even do anything. It does it for you. So we go to, let's say, flow front velocity vector. We zoom in on this point, and it shows us the actual velocity of the plastic at these separate points. Obviously, this big red one is the injection angle, so it's going up really, really hectically. But as you can see how it actually flows through, it even gives you an idea of the fibers. Ease of fill. So we assume the whole part's pretty chilled. It'll be easy to fill, no worries. Then we get bulk temperature at ejection. So it shows you the temperatures, or I think at fill, whatever, it doesn't really matter. Air traps, shows you where the air traps will be if we use that injection location. These are all very, very accurate and verifiable results. You can see these little, it shows you where the wild line is going to be. So you would expect there to be wild lines on this little bracket, so you just have to hope this little air intake location, you expect there to be that, but that's pretty normal, so it's probably fine. Then we can go to sig marks. It shows us where the sig marks is going to be, where we're going to have little marks from the cooling of the actual part. So you can see different cooling temperatures can cause that. You can also see the areas that are frozen at the end of the fill. So yeah, I mean, you can see in it really, look at all these different things. These are all just auto-populated. You can even populate more if you choose. It's completely up to you. What else? I think I've shown all of them. Let's see what else. There's freezing time at end of fill. You can see there's so many different features. Then you can even do ejection time. So it shows you probably can eject it 9 seconds. It's up to you. Just depending on, there might be one little hotspot somewhere, but that's probably fine. Yeah. So you can show different transparencies. So yeah, that was my little plastics demo. It was really fun. I enjoyed it. But let me just really go through the summary. So, using SolidWorks Plastics during the earliest stage of part and mold design helps you. You can predict and you can avoid injection molding defects within, when you actually get to manufacturing. You can eliminate the costly mold rework. You can improve the part quality, and you can decrease your time to market. So that's essentially what we've been talking about a lot. Is you can improve your plastics outputting. You can output more parts, you can output better parts, and with more confidence in your results using these tools. And the thing to keep in mind is your return on investment is almost immediate. You will get your money back. So I would recommend you to take a look at this. Thank you for watching. I appreciate it. And thanks everyone for attending live and for watching this. I really enjoy these, and it's nice to talk to you. And yeah, I hope you all have a great day or night or wherever you are in the world. And please, MeCAD Systems, that's who we are. Please reach out to us. We would love to hear from you.